Welcome back, guys. Today we are going to talk about Sora. It's a new text to video model created by Long while maintaining the excellent visual quality and adherence to the user's prompt. Now, we have been waiting for the technical paper on how this model was made, but now we have the technical paper and I'm gonna attach the link in the description. In the research part, what OpenAI has mentioned is that they've explored large-scale training of generative models on video data. Specifically, they have trained text conditional diffusion models jointly to make it more simpler. But what OpenAI has done is to take variable duration, variable resolutions, and variable aspect ratio. OpenAI has leveraged the transformer architecture, of course, that operates on space-time patches of videos and latent codes of images. The largest model, they're calling it the Sora, is capable of generating, again, a minute of high-fidelity videos, and the results suggest that scaling videos generative models is a promising path towards building general-purpose simulators of the physical world. Now, do you believe that this is a stepping stone for the AGI? I believe so. Technically, they have taken inspiration from large language models, which acquire generalist capabilities by training on internet-scale data. The success of the LLM paradigm is enabled in part by the use of tokens that elegantly unify diverse modalities of text, for example, code, math, and various natural languages. In this work, they have considered how, generative models of visual data can inherit such benefit. Where LLM have text tokens, Sora has visual patches, so they call it patches. Now, patches have previously been shown to be an effective representation for the models of visual data. OpenAI team has found out that patches are a highly scalable and efficient representation for training generative models on diverse type of videos and images. Now, talking about the video compression network, they have trained a network that reduces the dimensionality of visual data. This network takes raw video as input and outputs a latent representation that is both compressed temporally and spatially as well. Sora is trained on and subsequently generates videos within this compressed latent space. They've also trained a corresponding decoder model that maps generated latent back to the pixel space that we can see. Now, what is this space-time latent patches? Well, given a compressed input video, they can extract a sequence of space-time patches which act as transformer tokens. This scheme works for images too, since images are just videos within a single frame. Their patch-based representation enables Sora to train on videos and images of variable resolution, duration, and different aspect ratios. At inference time, they can control the size of generated videos by arranging randomly initiated patches in an appropriate size grid. That is pretty cool. Now, this is a diffusion process, which means removing the noises. So Sora is a diffusion model, given input noisy patches at first and conditional information like text prompt, it's trained to predict the original clean patches. Sora is a diffusion transformer. Okay, so there are two terms like diffusion, which is the removal of noise, and transformer architecture that we are all aware of. Now, transformers have demonstrated remarkable scaling properties across a variety of domains we know, including language modeling, computer vision, image generation, and Sora is built using that transformer technology. They have tested out different type of compute. In the base compute, the image, the video may not be too obvious and a good video, but with the increase of compute, they have found out an excellent output when we increase the compute. Now, if you look at the demos of the videos that we see that the outputs are pretty amazing. Sora is able to generate complex scenes with multiple characters, specific type of motion, different camera angles, and accurate details of the subject and the background. Even when the subject is moving, the background, the logos and every aspect of the background is constant. The model understands not only what the user has asked for in the prompt, but also how those exist in the physical world. Which means, if you give a prompt, for example, a man walking through the desert, so that it will honor that prompt and start up a video. But for continuation of the video, it's gonna use the physical world, real world knowledge that it has. It has the knowledge of the physics interaction. Well, it's not how the real engine works, but it's being generated pixel by pixel, and it knows how the physical world exists in the real world. So it is going to use that knowledge and integrate your prompt and its existing knowledge to come up with this video. Right now, Sora is becoming available to red teamers to access critical areas for risk and harms, and I'm sure there will be so much modifications to be made. As I like to say, this is the worst that Sora can be, and tomorrow we will see a better model than today. But I'm really looking forward to test it out. We also, they're also granting access to a number of visual art search progress early to start working and getting feedback for people outside of OpenAI, and to give a public a sense of what AI capabilities it can have. Now, the model has a deep understanding of language as well, enabling it to accurately interpret the prompts and generate compelling characters that express vibrant emotion. Sora can also create multiple shots within a single generated video that accurately persist characters and visual styles. Does the model have any limitations? Yes, of course, every model has limitations, and we are moving forward for a better future. The current model, Sora, has some weaknesses as well. It may struggle with accurate simulation of the physics of the complex scenes, and may not understand specific instances of cause and effect. For example, a person with camera trajectory. Now, regarding the mixing up of the left and right, we have also seen problems in image generation softwares as well, where the left and right are mixed up because the reference could be the person who is watching, or the reference could be the person whose image you're drawing. So it has the tendency of mixing up the left and right. Of course, one big achievement is that what I see is that the hand is interpreted and constructed correctly. Now, Sora since it's built on past research of DALL-E and GPT models, it uses the recapturing technique from DALL-E 3, which involves highly descriptive captions of the visual training data. As a result, the model is able to follow the user's text instruction in the generated video more faithfully. In addition to being able to generate a video solely from text models, the model is able to take in an existing still image and generate a video from it, animating the image's context with accuracy and attention to small details. But this is just an intro. We are not yet able to get our hands on and try a few prompts of our own, but I'm really looking for the better version of Sora. This is historic, and I will see you next time with more interesting videos. Thank you so much. Have a nice day.